And good morning, all my favorite superhumans. I've got audio. Oh, my computer is stuttering like crazy. It's having a bit of trouble at the moment, and I don't know quite what it is. Hopefully it's coming out reasonably smooth at the other end. YouTube is reporting that the connection is good, but the question is, am I very out of sync? Okay, that is not good. Let me see what is going on here. I might quit out of a couple of things. My computer is rather old and I think it might be struggling. So I'll quit out of Fusion that I happen to have running, and that might free up some memory. What else? Not much else I can quit out of. I've got OBS and Eagle running. We'll probably need Eagle at some point. Yeah, audio is fine, it's only video. Alright, what I can do is switch cameras. Give me a second. Side, front, let's see if this camera works. Okay, this is the internal camera. So this is the camera built into the iMac. Don't quit OBS. Thanks, James. I'll try to do that. Oh, Matt, so running OBS as admin apparently causes it to have higher CPU priority. That's interesting. Yeah, okay. There is something very strange going on with my computer, and I'm seeing it here locally too. In the preview window, I'm only getting like 2 frames a second in OBS. Alright. Install Linux. Yes, I've got Linux on my secondary machine, which is the other row of monitors directly above this. And I've been thinking it could be interesting to try running OBS on the Linux box instead. That might make things a bit better. So if the lag is still there on the internal camera, I think I'm going to switch back to the better camera. Oh, that looks horrible. I can see in the preview window. If you don't look at my mouth, maybe it's not so bad. Then it doesn't look like it's so far out of sync. Alright, I'm going to try something because this is going to be terrible if we have to go through this for the next 2 hours. What I'm going to do is unplug the camera connection, plug it back in, and see if that makes any difference. So I'm going to switch to, what do I switch to? Let's go to the microscope view, just so that you've got something visible there. I'm going to unplug the camera entirely. Plug it back in. And let's see if the cam link comes back. Doesn't seem to have so far. Ah, okay, it's back. And it looks smoother. Going back to the front camera. It's smoother, but I think it's still laggy. Yeah, smoother. Okay. Alright. Hopefully this isn't too annoying. The video actually looks alright now in my local preview. It's just that I think the audio is very slightly out of sync because I'm capturing the video through a cam link and then I'm capturing the audio through an external microphone. So, alright, we'll go with this. So I just wanted to say a huge thank you to a viewer who sent me a cam link. Now I'm only seeing 5 frames per second here. That is really strange. And yeah, thanks Sion, I will push on. I don't know what's going on with that frame rate. That is very weird because my internet connection is fine and YouTube is reporting that it's not congested or anything like that. It says it's got an excellent connection. Alright. Oh, okay. One thing that'll be interesting to try. Let's see if we can eliminate the camera, and I'm going to switch to desktop. So right now, well, you still see the camera, but you can see Eagle there. Ooh, okay. So I'm gonna, well, just zooming around. Eagle is kind of choppy even locally, so that's not a good test. But maybe looking at the screen is not as laggy as looking at the monitor. That is going that is looking really choppy even to me, just on the desktop. I think it's my computer. I think my computer is having a hard time. It's trying to do too many things at once. Alright, I'm going to quit out of game capture, which means I will lose the microscope, but I don't think that's going to matter. At this point, I'll just do whatever it is to try to make the computer run a bit better. Okay. Yeah. The big problem with rebooting is that if I do that, I'm going to have to reinitiate the YouTube stream, which means it'll create a new stream, and then we've got to get the URL for the new stream, and then everybody has to jump over. Okay, camera looks fine now. Let's switch back to the front camera. Maybe it's improving now. What I found is that if I run the game capture software, the Elgato game capture software, it tends to put a whole lot of load on the system, and I think it's the way it processes the video is quite laggy. So hopefully that's an improvement now. Oh, fantastic! No reboot required. Alright, so back to what I was just about to say. A couple of weeks ago, I was sent this microphone by Guru of Nothing. So he's really helped fix my audio problems. Thank you very much. And just a couple of days ago, I received a Camlink, one of the original Camlink models that was sent by a viewer in Sydney, I think. So right now what I've got is my Panasonic camera connected by HDMI into the Camlink, which is then being picked up as a webcam by OBS. And this is so much nicer to work with than using that game capture, because with the game capture system I have to run the game capture software, which displays the video on screen, and then in OBS I have to capture a portion of the screen, so it's doing like a live screen capture and then using that, which is multiple layers, and it's pretty horrible. Camlink is so much better. Okay, I think we're ready to go. Now, I was serious earlier about saying that I have no idea what I'm going to talk about today. So if there are questions and things, we should just pop them in the chat. But just for the fun of it, and because people were asking about it last week, that big yellow thing in the background right there that you can see. Oh, John says, I see a familiar feeder on your desk. Yes. So this is a feeder for my pick and place machine. I was just putting this one together. This is an 8mm wide feeder, and I pulled it off because I substituted a 12mm feeder in its place, and this is going to go into a different location on the machine. I've just made another 4 12mm feeders, which is going to pretty much fill all of the space I've got available on the front of the machine. And I haven't even opened them yet, but I just received this shipment from All PCB, which has got some new boards in it. And one of these boards is a feeder linker board that goes between multiple 12mm feeders. So the way feeders are normally linked Well, the way these particular feeders are normally linked with OpenPNP is you have a four-way I can't speak today. A four-way cable coming off the bottom of every feeder, which is ground power. There is a sense line which comes back from the peeler tape sensor switch, and also a PWM input which goes to the servo that does the tape advance. And that ends up with a really big bundle of wires. So what I designed is a little PCB that has a row of connectors on it, and you put this into a few, this goes into 4 feeders that are mounted side by side, and it gives you an IDC connector. So you have a single IDC cable that comes off for every 4 feeders. And I designed one of these a little while ago to suit the 8mm feeders, which are these ones. But now that I've got some 12mm feeders as well, I've just designed this version, which is just a little bit longer. It spaces the feeders out more, and that fits the 12mm feeders. So you just saw me open the packet. I haven't even assembled one of those yet. But what that does is connect into the little PCB, because there is a PCB like this inside the bottom of each one of those feeders, and that's what links to the servo and the motor and the tension switch and all that stuff. Okay, see, we're a couple of minutes in and I'm already off on tangents. Why not use a 90-degree micromotor? Okay, I did actually use a 180-degree micromotor. I experimented with that. Now, there's a trade-off. So, what Aaron is asking about here is this feeder consists of 2 parts. There is the main body of the feeder, and then there is a tape peeler that sits at the back. That's actually a separate assembly. It's held on by a bolt just in here, little M3 bolt, and a couple of tabs that interlock. So what you do is slide the peeler in, clip it up, and then put one bolt in, and that fixes it in place. And you can see this one is mounted on the top location. There are 3 positions on the feeder where this can go, so top, middle, bottom, and that is because the feeder is wider at that point. This motor sticks out the side, and it would be really nice if the entire feeder was contained within this profile, but the problem is that this motor sticks out, which means that if you have feeders side by side, they need to be at a different vertical position, so they stagger like a staircase. So you have one at the top, then you have one in the next feeder along will have its peeler on the middle position, and the next feeder will be on the bottom, and by the time you've got to the 4th feeder, there's clearance to have it at the top again. So they go in a little staircase sort of arrangement. Now, that is kind of annoying, because if you're taking feeders in and out, the motors get in the way as you're trying to move them. So I've got, so this is the original design of the peeler that came, that Michael designed to go with this. There are third-party designs as well. Where is it? Oh, there it is. So people have tried to solve this width problem, and I've tried to solve this width problem. I was unsuccessful. Other people have been more successful. Oh, and this is the problem that I was solving with that little breakout board. So instead of having a huge bundle of cables coming off the controller, and then one of these cables going to each feeder, I now just have a small IDC cable going to each set of 4 feeders, and it's so much nicer. But in here, I have parts for another feeder, another peeler. And this is a totally different design, and it's designed to remain entirely within the profile of the feeder. So, this is all in bits. It's Yeah, it's kind of incomplete, so it's a little bit hard to explain, but this particular design uses a servo that has been converted to continuous rotation. So this is a micro servo, yeah, like a 9G servo that has been modified for continuous rotation, and it uses that instead of the N20 motor. And the servo mounts in here, and then there is a worm gear that goes in here. All the bits are in the bag. And so this particular peeler mechanism, so this mounts on the back of the feeder in the same place. So instead of having this peeler, you would have this one that mounts on it, and it does the same job, but it's as wide as the feeder. It doesn't have this protrusion. And I made up one of these peelers as an experiment just to see what it was like, and I didn't really like it. What I found is that the converting the motion this way using the worm gear was not very good, because the gears are 3D printed, and the force involved with a worm gear involves the teeth sliding against each other, and it really didn't work very well. If it had like a metal worm gear in there, it would be a whole lot better, or if they were printed out of nylon or something like that, it might be better, but it just didn't work all that well. I'm getting quite warm here, so alright, so that is one solution to the width problem. Another solution to the width problem is so this is getting back to, I think it was Aaron's suggestion, was using a 90-degree motor. These little N20 motors come in a couple of different styles. This is the standard style. Ooh. It's a tiny little motor with a gearbox on the front, and the shaft is just in line with the original motor shaft. But that's not the only way you can get them. Do I have any? Not sure where they are. But you can also get them with a 90-degree bend, and you can get them with a 180-degree, which is really interesting. So the gearbox comes up here and it goes across sideways, and then the shaft goes back in the direction of the motor body, and the whole thing is reasonably short. So I do have some of those around somewhere, just got to find them. No, it's probably not worth the time. You understand what I mean anyway. So to reduce the overall width, I made some changes to this peeler mechanism, and in fact my changes have been merged back upstream into Michael's master copy, and you can see one of the changes on here. Just under here there is a little curved face. The bottom of the body here in the original design went straight across, and what I did was bring a curved clearance up here, and the reason for that is to allow a 180-degree motor to be fitted, where the shaft comes out the side, there's the gearbox, it goes down, and then the body of the motor, so all of this, is back underneath here. And that does work, but what it does, and it makes the whole thing about half as wide, but what it also does is make the peeler higher vertically. So you still need to overlap them, but you overlap like every second one, so it's high, low, instead of high, middle, bottom, high, middle, bottom. So instead of a three-way repeating pattern, it's a two-way repeating pattern. And that does work, but it doesn't solve the fundamental problem. Ideally, we want the entire peeler to be within the profile of the feeder. So the issue is, if we use a 90-degree, well, the basic problem is that the angle of motion has to be on a gear which allows the tape to go straight down through it. So we need a gear that turns this way, which means we need a shaft that goes this way. So even if you use a 90-degree motor, you still have the body of the motor hanging out the side, and you still have the clearance issues. And if you rotate the motor so the body is behind, you then have to translate the motion 90 degrees or twist the tape 90 degrees as it comes down through the peeler. So there aren't really great solutions there. It's one of those things where there is no one perfect way of doing it. There are trade-offs everywhere. So, okay, so John said, yes, those are the ones I use now. So, John, I wasn't paying attention, so I'm not sure what you're responding to. I assume you mean these ones with the continuous rotation servos, and I'd be interested to know what you think of them, whether they've been working well for you. Cool, thanks John. So if you've got opinions on those, I'd love to hear them. Alright, the handy tech, I'll get back to your question in a second. Oh John, they work great for 8mm. Okay, cool. So, Aaron asked, would a larger worm gear on the opposite side of the drive gear work? Possibly. It's, yeah, I don't know. What it came down to is that I messed around with this and I tried a few different versions, like this type of peeler. I tried modifying this design, and in the end I just needed to keep going, so I just standardized on using the design as Michael intended, and I've got that on. I currently have this on all of my feeders, and it's working pretty well. So yeah, it was one of those things where I could have kept spending a whole lot of time messing around with optimizing the peeler design, and I decided to just move on and do other things and live with the limitations of having the feeders all interlocked. The other trade-off to consider is that loading tape into these feeders is a total pain in the ass. And if you've got a brand new reel, it's easy. You push it up through the bottom and feed it through, and then you grab the leader and you pull it back. But if you have a reel that has been partly used and then the reel has been cut off, it's really tricky to load these, and particularly because they have to be loaded in place. With most feeders on pick and place machines, they will have something like a plate on one side, and then there is a little hanger. So what you do is you have the feeder out of the machine, you clip the reel onto it and you feed it through, and then you have a preloaded complete assembly with a handle on it, so you can then take that prepared assembly and clip it into the machine. The problem with these is, because the feeders stay permanently attached to the machine, you end up having to load the tape while it's in place, and that's really awkward, because if you imagine that you've got a whole lot of these jammed side by side and you've got feeders on both sides that already have their tape loaded in them, the space you have to work in is the width of the feeder, which is, I think it's about 14mm or something. Yeah. So you've got 14mm of width to try to be reaching in and feeding the tape in, and you're bumping the tapes on either side. It's a real pain. So the result is that what I found in practice is that the extra width on these feeders on the peeler doesn't matter, because I don't take the feeders off. I'm not regularly taking them off to change reels, which you would do with most pick and place machines. These feeders stay on the machine, and if these are all interlocking, it doesn't matter, because they stay on there for years at a time. And if I need to replace a reel, then I feed it in from the bottom and away we go. So it's one of those things where, yes, optimizing it would be good. You could come up with a better design that had the feeder totally self-contained. One thing that I have thought about doing, and decided that I didn't have the time to pursue it, is doing a version of this feeder that fits onto an aluminium plate. So what I could do is use something like a laser cut aluminium plate on one side, which would protrude down and have a hanger for mounting the reel on it, and that would make the whole thing self-contained. At the moment, my reels are just sitting in a little, sitting down below this on a couple of rails so that they can rotate, but they're essentially sitting loose under the machine, and it would be nice to make it self-contained. But once again, I could spend so much time optimizing that and coming up with new feeder designs, and at the end of the day, it's not really going to give me a huge benefit, so it's a trade-off. Okay, so there was a question back here about multi-press on Tasmota, and I've spent a whole lot of time talking about pick and place and various things on these live streams, so it'll be interesting to talk about some other home automation-y type topics. So the question was, where were we? The Handy Tech said, what do you think of the new multi-press button functionality of Tasmota? And I think it is very cool. I haven't, conceptually that is, I haven't used it personally. I'm on the Tasmota Discord, like in the private developer section, so I've seen like behind the scenes discussion that's been going on with the development of it, and it looks like it's the sort of thing that will be really useful, because we're dealing with a very limited user interface. It's like the classic thing of the Macs only having one mouse button, and how do you create a user interface that gives you more scope of interaction when you've only got one thing to interact with. And I think it's cool in some ways. A lot of the time though, when you're interacting with a Sonoff or a similar device running Tasmota, the device is going to be locked away somewhere. It'll be inside a ceiling or built into something. So it's not really all that often that you have a Sonoff exposed and the button that you can get to, except in the situation of things like the Sonoff Touch, where it is the actual switch. It's not just a device that's built inside a wall. And in that situation, having multi-touch, well, not really multi-touch, but like multi-press or whatever functionality could be really cool. Things like doing long presses for dimming and those sorts of functions. So for me personally, it doesn't matter, because I have my own light switches. I don't use the Sonoff light switches, and the Sonoff devices that I use, that I interact with, are mostly buried away. There are a couple of exceptions. There was a video I did years ago where I put a Sonoff inside a waterproof enclosure with an external button on it, and I have one of those in my garage, which is just through that wall over there, and I do actually directly interact with that because I've got the Sonoff inside its weatherproof enclosure attached to a bit of shelving, so I've got storage racks out there for all of my stock, and I use the button on it just directly to turn all the shelving lights on and off. But that's pretty much the only thing where I have a Tasmota device where I interact with it directly using its button, beyond just like the initial setup. So I would be interested to hear what other people would do with that multi-press functionality. Okay, this is getting into the subject of user interfaces where I kind of have some strong opinions, and I'll try not to go off on this tangent too much. A long time ago, I did a conference talk where I talked about part of my philosophy of user interfaces, and it can be summarized as the best user interface is no user interface. And by that, what I mean is things should behave the way you expect. The ideal situation is you're interacting with something. Well, the ideal situation is systems should do what they need to do without you having to tell them. They should understand what's going on and react to changing requirements without you specifically saying, turn this on or turn this off. Now, a good example of that is a thermostat, because it's a closed loop control system. You can tell it, you can manually set initially, I want the temperature to be 21 degrees or whatever in your house, and it is trying to maintain that. So you don't have to manually turn your heater or air conditioning on and off, toggling it to try to track that temperature. The system is tracking the temperature by itself. Now, that is an example of a control system, like a closed loop control system, that is taking care of itself. You don't need to be manually turning it on and off. It's a kind of crappy example, but it was the first one I could think of. So what should happen? Okay, here's a better example. Door locks. If you think about the purpose of a door lock and what it's actually trying to achieve, so stop thinking about the specifics of a lock and how it works. Take a big step back and think, what problem are we trying to solve just by having that lock existing? What's it there for? And what it's trying to do is allow an authorized person to travel through a door, and it is trying to prevent an unauthorized person from traveling through the door. So that is your ultimate goal, and the lock is how you're achieving that. So the way we normally interact with a lock, so if you think about it, a lock is a user interface for a door. It's an authentication system. And the way you interact with that is that you have a physical key, or you might need to know an ID. So if you've got a digital lock, you can walk up to it and type the code into it. But you have to manually tell it your intent. You have to say, I want you to unlock now, either by putting the key in and turning it or typing in the code or whatever. So the user interface for the door is how you interface with the lock. Now, if you go back to the original concept of what is the purpose of the lock? Okay, it's to allow me to open the door whenever I want to, and it's to prevent other people opening the door whenever they want to. The ideal solution to that is if the door simply behaves the way you want it to, with no user interface. If you walk up to the door and you're allowed to go through it, you push the door or turn the handle or whatever, and the door is unlocked. It works, you can go through it. Someone else comes up to it and they're not authorized to go through it, they push the door and it doesn't open. So there is no user interface as such in terms of how you interact with the lock on the door. The door simply behaves the way you want it to behave. So that's really what I mean about the best user interface is no user interface. You shouldn't have to think about, I need the key to get through this door, or I need to know the pin to to open this lock so I can get in. The door should be unlocked for you, and it should be locked for everybody else. So that is the no user interface ideal situation. But it's not always possible to achieve that. So what happens is that we end up layering user interfaces onto things like locks with keys as a way of allowing us to control the behavior of the device instead of having the device behave the way that it should behave automatically and just taking care of those things for you. Am I even still on the subject? I have no idea what I was talking about. I've ended up going off on a best UI is no UI rant. And so this general philosophy extends to all sorts of things. What it comes down to is that the objects around you and the software that you use and the computers that you interact with should ideally respond in an intuitive way. It should be a case of, I think it should work like this, And so that's what you do, and it just works. It shouldn't be a case of puzzling over, if I do this particular thing and turn this option on, will that achieve my end result? If you are conscious of the fact that you are using a system or a user interface, then that user interface has failed because it is not behaving the way you expect it to. The objective of someone who builds user interfaces should be to make them vanish. Maybe not literally. There is typically still something there that you have to interact with. There will be controls and menus and buttons on physical devices. But the objective should be that those things simply work the way you expect them to. Now, of course, there are all sorts of cultural issues. There are different expectations. There are different there's different background knowledge. So some people might approach a system with experience in a similar system that uses a totally different user interface, and then it breaks their mind trying to use your user interface because it doesn't work the way they expect. They've been trained to work in a different way. A classic example of that is CAD software for PCB design. I've been using Eagle for so long now that whenever I try something else like KiCad, it breaks my mind, not because what it's trying to do is bad, and not because it's trying to do things in a bad way, but because my brain has now been trained to solve certain things in a certain way. So to me, the user interface for Eagle feels intuitive because I've been using it for so many years and designed so many hundreds of boards. So when I try to use KiCad, it could be the most intuitive thing in the world to someone without any background in Eagle or board design, but there's still that barrier to me because my expectations are different. So that, of course, is always going to be an issue. You can never make a user interface totally disappear because the point of a user interface is to take the intent of a person and then apply that intent externally. It's taking your goals out of your head and then making them happen. And that has to involve a user interface to some extent. We don't have direct brain interfaces yet, and even then there will still be some kind of paradigms involved. There are direct neural interfaces in prototyping stage, and there are systems where you can visualize certain things or imagine certain things, and the computer can detect that and then respond in certain ways. There are a few years ago, there were several products on the market that were like a skull cap that you put on with electrodes, and then you could think about certain things and you could make a mouse move around or play a game just by thinking about it. But even in that situation, there is still some mental construct that is taking your goal or what you want to achieve and then converting that into something that the systems around you can react to and deal with. So, bringing this all the way back to the original question, which I think was about the multi-press functionality in Tasmota, one thing I have a problem with is when interfaces or UI elements do different things depending on how long you press them or some other attribute. And I have this all the time when I'm trying to explain certain software to people. For example, okay, here's the classic example: the power button on a Mac. If you press the power button, it will start it if it's not running. You press the power button again, and it brings up a dialog saying, do you want to shut down? And then you interact with the computer and you say shut down or cancel or whatever. If you press and hold the power button for 5 seconds, then it just kills the power. Well, it does this on PCs too. If you press the power button on a PC and hold it, it kills the power. So this is not a Mac thing in particular. It's just the way computers work. I regularly, when I'm trying to talk non-technical people through how to do things on their computer, have a situation where I might be on the phone to them and say, okay, you need to shut down your Mac now, so press the power button. Or, that's one way of doing it. You can go to the menu and press it, but just for a hypothetical thing, say, okay, press the power button, because that's, in my mind, it's intuitive to go, press the power button, hit enter, and it's going to shut down. But to someone who doesn't have the same background or experience interacting with computers, when I say press the power button, they don't necessarily let go of it. So they will say, they'll press the power button, and I'll say, has the dialogue come up on the screen yet? And they'll say, oh, my screen just went blank. And it's because they'd held the power button down for 5 seconds, killed the power to the computer, and now there could be data corruption, or could be all sorts of bad things happening. And it's because I didn't think to say, just press the button and release it. And you have to say things like, okay, press it for half a second and let go, or press it for 1 second and let go. If you're not specific about that, then people will literally, you say, okay, press the power button. People will literally press the power button and then just not let go. So I have a general aversion to user interfaces where if you press a button once, it does something. Press it and hold it, it does something else. And I've seen quite a few user interfaces like that. I think some Clipsal stuff does this. If you look at smart home systems, what happens is that you're working with a very limited user interface. So you're working with something like a switch on a wall, and you have one switch or button that is matched to one particular light. But you want multiple functionality out of it. You want the obvious thing like press it once and it turns the light on, press it again, turns it off. But a lot of systems then take that and try to extrapolate more behavior out of that extremely limited user interface. You've got one button, so what do? Well, how about multi-press? How about extended press? So you see quite a few systems where they'll do things like you press it once and it turns the light on, but if you press it and hold it, it goes through a dimming process or like a ramping up process. And so for someone who isn't expecting that, it's the same as interacting with a power button on a computer. If someone comes into your house and you've got a C-bus system or something that implements this time-based button press, and someone wants to turn off the light, you could say to them, just press the button. And they press the button and release it and the lights turn off, that's fine. You say press the button, they press the button and hold it, nothing happens for a second, and then the lights start to slowly dim. And then what happens is that in their mind, that's just reinforced that what they're doing is the correct thing. So they then think, I've got to press the button and hold it and wait for the dimmer to bring the illumination level down to off, or close to off, and then they let go. And if they make that mistake the first time they interact with the system, in their head then will be stuck the idea that you have to turn the lights on and off by pressing it and holding it, and then the light level ramps down. And so they may totally miss the idea that you can just press it and let go, and the lights will just turn on and off. So that might sound silly. And if you're experienced with technology or home automation systems or whatever, you might think, oh, people won't do that. But think back to, if you're a technical person, think back to all the times that you have been trying to help non-technical people through something with their phone or their computer or home automation system or whatever, and how specific you have to be in describing exactly what to do. Like press the button and release it, not just press the button. And it's going to trip you up. So it's really tempting as someone who does understand the technology to try to layer more options for interaction onto a user interface and have hidden functionality or extra things that do things that when you don't expect it. Now, one piece of software that does this, and it kind of drives me nuts, although it has got better in recent versions, is Grafana. The user interface to that is almost totally inscrutable. It's typically an edit-in-place system which I actually kind of like. That is quite cool. Oh, a comment here. My eye happened to fall on it. James said, technology done right should be imperceptible from magic. Arthur C. Clarke. Yeah. So any sufficiently advanced technology is indistinguishable from magic. Things should just do what they should do. Where was my brain going? I have no idea. All right. Oh yeah, that's right, Grafana. So I've used Grafana quite a bit over the years and through many versions. I had a Grafana, the Grafana interfaces I just upgraded were still running Grafana 3.6 or something, and they're up to like version 7 now. And it has changed a bit over time, and I think it's improved in this respect. But one of the interesting things about the Grafana interface is this edit in place system. The very brief recap for people who have never heard of Grafana is that it is a front end for building charts and graphs from data. So you can use it to make dashboards for different things like plot temperature over time and that sort of thing. So I've been using it for doing things like plotting the values coming back from my air quality sensors. I've been using it for years in my house for plotting, all the classic stuff, temperature and humidity and those sorts of things. But I've specifically been using it because I've been playing around with the air quality sensors and sticking the data into InfluxDB and then charting it all in Grafana. And what it reminded me of is the frustration that I first felt when I began using Grafana years ago, and I couldn't figure out how to do anything because everything is hidden under these layers of the user interface and things that you interact with in ways that are not necessarily intuitive. Like there won't be a button to do something. The action will be hidden in some way, like dragging things around or in some context that you have to get into, but you can't see how to get into the context. And I think from memory, this is stretching my memory now, I think it used to have a bit of a mystery meat navigation problem as well, where there were icons on the screen with no text on them, and if you didn't know what the icons did, you would have to kind of puzzle over them. So it's one of those situations. Mystery meat navigation is where you have navigation on the screen and there's no explanation of what it is. So what you often need to do is move the mouse over the navigation item and sit and wait for the tooltip to pop up, and then the tooltip explains what that icon does. And then you move on to the next one and the tooltip pops up and it tells you what the icon does. But the tooltip for the previous one is no longer visible, so you have to remember the connection between the icons and the actions. So the result is that the user interface, if you've used it for a long time, it's fine, you know what that icon does. But the first time you come in to use it, you're slowly moving the mouse around, moving it over the different UI elements, and figuring out, oh, what is that? Okay, that's the edit icon. And what's this one? Oh, this is settings. And what's this one? This is save. And they're not necessarily all that obvious. Like, people use different icon sets. So when you're still trying to come to grips with a new user interface and it uses this sort of mystery meat navigation paradigm, what will happen is that you'll have a series of icons and you're trying to figure out which one to use. So you cursor your mouse over the first one, and then you move to the next one, and you move to the next one, and then 2 minutes later you'll find yourself back mousing over the first one and waiting for the tooltip to pop up, and then it comes up and you go, oh, that's right, that's what that icon does. But you can't just look at the user interface and say, that is the item I need. That level of familiarity has to be built up over time. Now, I think that is actually one of the issues with the Eagle user interface as well, because it's got all of the tools down the side. In fact, I've got it on my desktop open right now. It's got all of the tools down the left-hand side here, and these are not necessarily intuitive. I mean, there's a big letter A. That's the classic thing for a text tool. But there are other things like there are 2 green dots and a line between them. What the hell is that? So I don't actually have focus on this window right now, which means the tooltips are never going to show up. But if I bring it into the front and I go over that, okay, that's a signal. But even that doesn't tell me much. What does signal mean? And change. And it's got these little icons that are quite similar. There's a jaggy line with a lightning bolt next to it, and there's one with 2 lines through it. What do the 2 lines mean? Why is that different to the other one? So, because this is the situation where I've been using Eagle for so long now that I do actually know what those icons mean, and I can just go, that's the tool I want. And in fact, I have a custom keypad here which sends Eagle macros. So typically I'll have my left hand on the custom keypad, and I can just press one button and it sends text into the Eagle command line and it executes functions. So I can call up different tools and different modes and things just by pressing one button. But once again, that is a muscle memory familiarization process. Okay, so I am so far off the track. Okay, so here is a great question. James asked, do I label my light switches around the house? No, but I want to. And I originally thought that it would be intuitive enough that I didn't need to, because they are a direct one-to-one replacement for regular rocker type light switches. So in a room where you have a light switch, just say 2 switches, and you would normally have 2 rockers. Now there are 2 buttons in their place, and I thought, oh, people are just going to figure that out. The other thing is I couldn't work out a really nice way to do the labeling that would look attractive, and it's something that I really want to come back to. I would very much like to be able to have custom labeling on the switch panels so that we get rid of this whole mystery meat navigation thing. I mean, light switches are a classic example of mystery meat navigation. Every single light switch looks the same. It's not even as if you've got different icons that you can figure out. The only thing that differentiates them is the context. So imagine if you're using a piece of software and it had a whole bunch of icons, and every single icon for all the tools was exactly the same icon. That's kind of like what the interface is for a house. And the only reason that you know that this switch controls that light is that you're in that particular room, or you're near the thing that the switch is controlling. And of course, once you get into home automation, you start to lose a whole lot of that. You lose a whole lot of that context. Because it's so easy to add extra buttons or switches. And this is something that bit me, I think, because in a typical house, what you'll find is 1 light switch per room, unless it's a passageway and you'll have a dual switch set up, in which case it's still obvious. There'll be like a single switch at each end of the passage, and you flick it and you walk through the passage and flick the other one, and it's all fine. It does what you expect because we've been trained to interact with the house over years of experience by doing it that way. But the thing is that once you start putting in some kind of a smart light switch or a home automation system, it's very easy to expand the switch panels. So in a situation where you might have a room, like, okay, a classic example is a master bedroom in the house here. Now, in a standard bedroom, there is a single light switch just inside the door, and like a single switch plate with a single switch on it. Anyone that walks into that knows exactly what it does. You flick that and you know the lights are going to come on. But once you have the flexibility of being able to add extra buttons and have them do other functions, the switch panels end up growing somehow. For example, the switch panel in the master bedroom here has 3 buttons on it, not 1. And the top one is the main overhead lights, as you would expect. The second one is lamps, sconce lamps that are on either side of the bed head. Now, normally what would happen in a traditionally wired house is you would have the single light switch for the room, and then things like the lamps would be controlled at the lamps themselves. But because the lamps are controlled by the home automation system, it's easy to also add an interface on the wall. So what we did was added a switch so that when you press the second button, you can turn both lamps on and off. It's convenient because if you're walking out the door, you can press the button and turn off the lamps. You don't have to walk around the bed and turn them off. And then there is a third button on it which opens and closes the blinds, because we've got electric blinds. So now if someone goes into the room, they don't have any background of how the house is set up, they've never interacted with it before, instead of a single light switch with a simple thing, flick that and the light turns on, you don't even think about it. You walk in and there's now a panel with 3 buttons on it, and they all look exactly the same and they're unlabeled. So for someone else coming into that for the first time, they're going to look at it and go, I have no idea what these do. And it will really be mystery meat navigation. They'll press the first one just to see what happens. And then you have to remember. So next time you come into the room, you have to remember that the bottom switch is the one that opens and closes the blinds. Now, we have this situation in the bathroom as well, like the main bathroom, because there are also electric blinds in there which open, the blinds cover 2 windows that go out into the backyard. And in there it's a 3-way switch. It's very similar. Top one is the main lights for the bathroom, the middle one is the exhaust fan, the bottom one is the blinds. And what happens all the time is if someone comes over to visit and they want to go to the toilet, what they'll do is they'll go into the bathroom, they're faced with this mystery meat navigation situation, so they'll press a button to see what happens. Press the first one, the lights turn on, that's fine. They press the second one and the fan turns on, that's fine. And then they press the third one to see what will happen, and the blinds start to open. But they're in there to go to the toilet. They don't want the blinds open, they want privacy. So then they're pressing the button again, trying to make it close, and it's all very confusing. And that's a situation where the user interface is not intuitive and it's not doing what you expect it to do. And for that reason, I really want to put some kind of labels on the switches, because it just reduces that friction. It allows someone to walk up to it, and if you've got a light symbol next to one and a fan symbol next to the other and a picture, I don't even know how you'd represent it, a picture of the blinds on the third button, then you can look at that and think, oh, that is going to do what I expect it to do when I press that button. Probably the major reason that I haven't done labeling yet on any of my light switches is I want to figure out a way to do it in a way that looks nice. And I just haven't put enough thought into it. It's one of those problems that I need to put some effort into solving so that I can come up with some way of labeling things that's not going to be ambiguous, it's going to be intuitive, and that I can do in a reasonable way. Things like stickers are ugly. I could, if you laser engrave into the plastic, then it gets charred, it doesn't look good. I could CNC machine some letters into it and then maybe put paint into the engraved letters and then wipe over the faceplate before it dries so that the letters are a different color. Another way would be something like a dye sublimation printer, the sort of printer that's used for things like merchandise. Like if you get a merchandise drink bottle and it's got a company logo on it, typically those things are printed with dye sublimation printers, and they are designed specifically for oddly shaped devices or oddly shaped objects. Like if you have a drink bottle, it's a cylinder, and you want to wrap a logo around it, that can be done in a few ways. Like you can use a foam transfer, like a sponge transfer type printer, or you can use a dye sublimation printer with a rotation axis in it. So you can put your thing in there and the printer can print over the curved surface. So I could use that sort of printer. I'd like to have one of those printers, but they cost a hell of a lot of money, and I don't know anyone that has one. Hussein just said use screen printing. Yep, that's an option. So screen printing takes a bit more to set up. That is traditionally how you would solve this problem if you wanted to make lots and lots of the same thing. It's not so useful in a situation where each room has different labels required. And of course there are things like the idea of using an LCD and then you can just change the labels in software. That's a possibility as well. And in the early days of this house, of the automation system in this house, I had more touchscreens around the place. I had little Android tablets, and I've got a few of them sitting in a box up there now that aren't being used. So with that, what I had was a user interface that had all the labels on it and buttons, and in that particular interface I had specific on and off buttons. So it would list what the item was, and then there'd be a green button to turn it on and a red button to turn it off. So you just walk up and press the touch screen. But once again, touch screens have their limitations. They're not tactile. You don't get a physical response because there's no haptic feedback in the touch screen, and you can't just press it without looking at it as you're walking past like you can with a normal light switch. So with a mechanical switch or button, I don't really look at what I'm doing. I'll reach out and grab the light switch because I know where it is, and I can feel that I'm pressing the top button. So you can do that while you're walking past it, or as you're coming into a room quite easily. You don't have to walk into the room, turn around, look at the screen, and then locate the button and then press it. So this is interesting. So James said, we print industrial labels all the time for the machines at work, die cut and all with nice labels. Yeah, that's interesting as well. So that can be done if you have either die cutting or using one of those craft blade cutters. You can do that sort of thing. And by that I mean like the Cameo silhouette sort of cutters where you feed some self-adhesive vinyl sheet into it and it's got a little computer controlled blade and it cuts shapes out of it. So that can be used for making labels as well. UV printed. So Vanquisher Beebs said you can get them UV printed too. And Dodgy pointed out the only problem with some kind of static label is when you change the switch function, like John did on his front porch light, you would need to change it again. Yeah, that's right. So the ideal for me would be some kind of a labeling system that I can do myself. James's offer of making some labels, that's really generous. Thanks, James. But the problem is that if I took you up on that offer and then you produce labels for me for all the different rooms, and then I want to change a switch, which doesn't happen very often. I mean, the last time I changed a switch was probably a couple of years ago. I would then have deviation from everything else. So I could end up with, I change a switch panel and now this one doesn't have labels on it, and then because I want to get new labels done, it might be a few years down the track and I might end up with labels that don't look quite the same as the others because they were done on a new machine, or we couldn't remember what font was used previously or whatever. So being able to do the labels myself on demand in a consistent way would be really nice. So what I'd like to be able to do is solve the problem of how do I make my own labels and do them on demand, so I can change them and keep them synchronized. Scott suggested a picture of curtained windows. Yeah, so that would be for the icon for showing which button does the blinds. And I'm kind of inclined to go with just text as well. So this is something that I'm really interested to get feedback on. Like, what do people expect and what looks reasonable? So what's intuitive, and also what is attractive in terms of light design. If you go into a house and there were labels on all the light switches, it kind of looks ugly. And how do you do that in a way that doesn't look ugly? Scott said China makes a few little desktop CNC routers, could engrave your switch plates pretty cheaply. Yeah, I actually have one. I've got a fairly large desktop CNC machine, which I don't think I've shown in any videos. It's down on the other side, near the corner of the door on the other side of the laser cutter. I have actually filmed some stuff doing that. Like, I've used that for making custom rack mount plates out of aluminium. So I've CNC'd the shapes out of the aluminium to make up brackets and mounting things. And I've filmed that for a SuperHouse episode about making custom rack mounting brackets, and I've never actually finished the video and uploaded it. But yeah, I do have a CNC machine, so I can do that. So Vanquisher suggested if your faceplate is semi-transparent, you could put an SMD LED matrix next to each button and have it programmable. Yeah, the issue is the resolution. Yeah, and as Scott pointed out, replacement switch plates are dirt cheap. Yeah, so if I CNC'd text into it and I wanted to change it, it wouldn't be a really big deal to throw out a switch plate and engrave a new one, because, as Scott points out, replacement switch plates are only a couple of dollars each. Because what I do is just get the blank switch plate and then I drill it out for putting my switches in. And of course, doing it this way, I could use the CNC machine to also do the holes for the buttons. So I could get it to engrave the labels and cut the holes at the same time. What I normally do is just use a cordless hand drill. The PCB for my light switches has markings on it for the spacings of where the holes need to go. So I just put the PCB on the faceplate and use it as a template, drill pilot holes, and then drill it by hand or on the drill press, depending on how enthusiastic I'm feeling. And I could just have that done by the CNC machine. Alright. So far I've been talking for more than an hour about I have no idea what. Let's have a look at some of these questions. I've been almost totally ignoring the chat, and there are probably a whole bunch of suggestions and things in here. So, just scrolling back through and glancing at it, Dodgy suggested LCD screen and the buttons. Yep, so that is the sort of thing that's done on things like some Clipsal switches, and I've thought about that. In the past, it would have been fairly expensive to do, but these days, little LCDs are so cheap that you could. In fact, I've got one right here. I use so many of these that all I have to do is glance around and I'll find a project that's got one on it. So this is the zero deflection for. No, what is this? This board is for the nurse call button, and it's got a little OLED module on it. It's a 128 by 32 OLED with an I2C interface. It's fairly small. In fact, the dimensions of this would be pretty much perfect for this application. And these displays cost, I'm trying to remember, it's something in the order of $2 or $2.50 each. It's so cheap. So it would be quite feasible if you had, say, a 3-gang light switch to have the 3 buttons and then have one of these OLEDs beside every button and then just display a text label on it. So that's possible. I just need to have the faceplate machined so that I'd have a slot where the OLED was visible. Yeah, I'd probably need something like a clear faceplate and then painting on the back of it with rectangles that aren't painted to reveal just the display, because you can't make a cut big enough to have the whole thing protrude through because the edges are all ugly. It would need to be with the plate overlapping the screen portion just up to the edges. But that means that this has to be set back from the face of the faceplate. So if you've got something like a plastic wall plate and then you have a rectangle routed into it and then mount this behind it, the display is going to be set back a fair way from the face, which is not ideal. But if this was, if the hole was big enough that the entire module was mounted inside the plastic, and then you had a clear plate that went over the front of it, so that this is flush with the back of the clear plate, that could look fine. If the plate was also painted on the back with just an open rectangle to reveal the part where the LCD is. So yeah, there are different ways that could be done. I don't know how long these displays last. Like if you have one turned on and displaying the same thing for 5 years straight, its backlight is probably gonna fade. You probably get burn-in. Not that you really care much about burn-in because this is just you're only going to be displaying the same label. One of the nice things is you could probably display status with it as well. Like if the load is on or off, you could change it, make it go bold font or something if the thing is turned on. Alright. So, let's see what other questions we've got here or comments. Oh, this is a good point. Ecognito3, who always has good comments, said, the problem with the magic bit is when they go wrong, the user is up the creek without a paddle in order to how to fix or otherwise work around the issue. Yeah, so this is throwing back to my earlier comments about the best UI is no UI, and if something mysteriously stops behaving the way you expect it to, how do you fix it? So yeah, that's something you have to consider as well. Like if you have automated lighting in your house so that when you walk into a room the lights turn on and then it stops working, how do you know what's happened? Yeah, and that's partly about logging and reporting and being able to inspect the behavior of a system. Yeah, big topic. Let's not get into that right now. Here's a funny comment. I've seen this one before. Richard Perrott said, mystery icons, when you find a 3.5-inch floppy and your daughter says, cool, you 3D printed the save icon. Yeah. And Dana said, so instead of going file save, save as, save template, you'd hover over save and scroll the mouse wheel to get save as. Yeah, that's the sort of crazy UI that people come up with when they're trying to simplify things. So that comment Dana said is in relation to the UI on a Windows 98 help desk app. When you open the menu and then hovered over a menu item, then scroll to change what the menu item was. That sounds terrible. The thing is though that we've got to try all these bad things in order to come up with the good things. We have to see these failures, and because we're still in the early stages of figuring out these computer things and what we can do with them. It's really nice that we do have some conventions now. I remember all the craziness that happened in the early days of the web. So for those of you that don't know, I started a web development business in 1994, and at the time most people didn't even know what the internet was. The number of people that had used it in any way was very low, and we were trying to figure out new ways of representing things, like how do you present user interfaces on a web type system. And when you're dealing with a new medium or a new type of technology, all you can really do is draw on your experiences with other things. And so in the early days of the web, what we saw was print media paradigms being applied online. And something you don't even really hear about these days is the concept of pages. It was very much around the idea of, I, as a developer or as a designer, have a strong concept of how this should be graphically represented, and I've designed this brochure or a poster, and now I want to represent this on the company's website. And so you'd see there things where a web page would just be a huge graphic, which was a direct representation of whatever was on the poster or the brochure, and it didn't adapt to different screen sizes or anything like that. And all of these sorts of concepts and things that we discovered, that you can't just take the existing design and transplant it into the new medium and have it work. You have to do things differently and think about things differently. It's taken a long time. But in the early days, when you're dealing with a new medium like that, all you can do is draw on your experience from other things that you have worked in, and then try to apply those concepts to this new method. So then you see a lot of failures, you see a lot of things that are really quite horrible, or that simply don't take advantage of the new things and new ideas or potentials that can be opened up by working in this new medium. And so you miss opportunities. But you have to go through that. It takes years to develop new conventions and new ways of working with something. What am I doing? Talking about random stuff from the 90s. Alright. Okay, James has made the point that CE certification strays away from text and uses pictograms and icons instead for industrial machines. Yeah, so this is part of the whole issue of trying to convey information in a way that is not dependent on knowledge of a specific language. And this is an area that I have looked at from the outside, but I have no idea what I'm doing in this field. The whole issue of graphic design and visual communication, and being able to take a concept. And so we've got this issue like, how do you represent a save icon? Like, what is a save icon? And we have, so the classic way to do it is the representation of the floppy disk. Right? That is what you see everywhere. And this comes back to that comment earlier about Richard saying that your daughter says, oh look, you 3D printed the save icon. Over time, the thing that the icon represented may not even exist anymore. So from the early days of computers, we knew that a disk represented a place where you were saving things. So we put the disk on the save icon. And then, you know, if I click this, it's going to save it to the disk. That's what it does. But then decades pass, new generations grow up who have never seen a floppy disk in their lives. To them, the icon is just the symbol that you click when you want to save something. They've got no idea what a floppy disk is. So it doesn't have that same, I'm going to use the word cultural, because I can't think of a better one. It doesn't have the same cultural association. So it becomes to them just an abstract representation of some action that you take. And the same sort of thing can happen if you are dealing with a system where you need to have people interact with it when they come from a different cultural background. Maybe they speak a different language. Maybe they come from a place where the way you represent a concept has a totally different convention. I can't think of any great examples right now. Like, this is, as I said, it's not my field. So visual communication and design is like a very complex and nuanced field, and I'll leave that to the experts. But then the question comes back to, if we're putting labels on a light switch, do I just literally put the English word light next to the first button to show that this is what you press to turn on the light, and put the word blinds next to the next one to show that that's what you use to open and close the blinds? Now, to an English speaker, that might be fine. To someone who's not an English speaker, it's not going to mean anything. But on the other hand, if I put a symbol for blinds, like a window with the curtains or whatever, that is something that someone can figure out no matter what their native language is. But it is harder to interpret than putting the literal word in the language of the language the person natively speaks. So if you have someone who speaks French and you put the word for blind in French on it, they're going to look at it and they're going to understand it perfectly. So there is less friction. This is just my perspective on it. As I said, I don't really know about this stuff. But the way I see it is that there is less friction if the labels and things are more specific to the person that is reading them. Like a label that is written, it says the word in their native language. They will understand very quickly what that is. However, there is more universality if you use more of an abstract representation, or a logo or a symbol or icon that represents the concept. That will be understood by a broader range of people, but there is more friction for all of them. So the classic answer to this, of course, is why not have both? Like the ad says, put a text label on there with a little icon next to it, and it reduces the friction for people that natively speak that language, but it also provides a more abstract representation that someone can understand if they don't speak that language. So my personal, if I was going to label things in my house, label the light switches, which I do want to do, I think it would be very useful in terms of reducing friction of the user interface. I think I would be inclined to go for a text label written in English, because even though that kind of excludes, and the other issue, of course, is you've got to think about user interfaces for people who are visually impaired. And this is really one area where touch surfaces are useless, because you've got no tactile feedback whatsoever. So interfaces for people who are visually impaired, you've got to have that tactile feedback, and ideally labeling in some method that they can understand, whether that is something as specific as the word in Braille, or a raised logo or icon that is in a shape that you can tell by touching it. So that's actually probably a good example of a situation where you want to make a user interface, like an interface to a physical object. I'm not talking about a computer interface here necessarily. That's a whole other area, where someone has to be able to interface with or interact with an interface like a switch, and they want to be able to do things like open the blinds, but it needs to be done all by touch. How do you represent that? All difficult problems. I don't have great solutions to any of this. I've spent way too long kind of thinking about it and trying to puzzle it over and not come up with good answers. One of my problems in terms of my own personality is that I'll look at a problem and I'll see multiple ways that problem can be solved, and none of them are perfect, so I don't do any of them. And I should just say, oh, that one's the 80% solution, so I'll just do that and move on, be done with it. But it drives me nuts when I know that I'm making compromises. So But engineering is all about compromises. We've got to cut our losses sometime and decide that we're going to do something that is the 80% solution. We know that there are problems with it, but at least we have something, and then we can evolve it and develop it on from there. I think it's probably partly a result of my personality of not wanting to, how do I describe this? When I was at school, one of my classmates said that my problem is that I try to please everybody, and he was absolutely right. I don't like making people angry. I don't like disappointing people. I try to make everybody happy, and you can't make everybody happy all the time. So when I'm trying to solve a problem, I try to make it solve all the problems, because I feel like if I haven't solved it 100%, then someone's going to be upset. Someone's going to be annoyed that I used text labels when I should have used icons, or I used icons when I should have used text labels. So I won't put any labels on there. Anyway, I should just do the 80% solution. So, Aaron said the Egyptians had it down 2,000 years ago with hieroglyphs. Yeah, cool. All right. Pad printed or screen? Okay, so pad printing, that's the term I was trying to remember earlier when I was talking about printing onto a curved surface. So there was a comment here from Dana who said they work so well for printing on flat items, but they'll print as well as a pad printed or screen printed item. So pad printing is when you have an object with an irregular surface and you want to transfer ink onto the surface. So there is a thing that, this is going to be a whole lot of hand waving. If you're interested in pad printing, you can Google pad printing and see how it works. It's really cool. But the very simple version of it is that you have some kind of a soft surface, which is like a foam pad that is on a piston, and it presses down onto a bed where there is ink and picks up the ink in the shape of whatever it is you want to print, transfers it over, and then it pushes itself against the object you want to print on. And because the pad is soft, it conforms to the shape of the target, and then you can do things like print around objects that are curved or things with an irregular shape. Oops. And because the pad deforms, of course, when the ink is being applied to the pad, it has to the shape of it has to account for the fact that it's going to be deformed. Now, what just happened here? I can see... last week someone said I should turn on Super Chat, so I went and tried to do that, and I didn't know if it worked, but I've just had a thing pop up, and it says £55. What does that mean? Oh, cool. So this was from Aaron, who said, contribution to getting the USB-C programmer with various Pogo Hat project completed. That is awesome. Thanks, Aaron. That's really generous. To be honest, I actually don't even know where that goes. I clicked the little thing to turn on Super Chats, and so Aaron has contributed £55. I think it's a pound symbol, towards getting that completed. Hopefully that will end up in, like, I don't know, in my YouTube advertising account or something. But, wow. Thanks, Aaron. All right, that has just moved my my Sonoff programming adapter project further up the to-do list. Yes, I can be bought. Let's see what other comments we've got in here. Oh, and scrolling down, so I've just got back down. So Aaron said, did you manage to progress the USB-C programmer with various Pogo hats for things like the Sonoff Mini from the last stream? I haven't, except for the adapter. The actual Pogo hat itself is done. I'd have to go and get it, and you saw it on the last stream anyway. They're designed for the 3D printable structure that holds the Sonoff Mini and the PCB that goes inside it with the pogo pins. That's all done. Like, I've used it and it works. I've plugged it in and reflashed Sonoff Minis using it. What's been holding that up is standardizing the interface for the USB-C adapter with the 6-pin header that plugs into it. And I've been wanting to make sure that whatever I go with on that is not going to be invalidated a week later by IT releasing a new Sonoff that uses some other header. And one of the big problems that I've had is that I've been going around and around on what USB to serial converter chip to use on it. I've used a few different ones over the years, and I don't like any of them. They're all annoying in different ways. I've been there's the classic, well, not the classic, yeah, okay, the classic FTDI chips, but I have a couple of problems with FTDI chips. They work well, but a few years ago, there was the problem of the drivers being updated and bricking existing FTDI chips because the company didn't like all of the counterfeits that were out there. Now, one of the difficulties is obtaining sources of FTDI chips that you know are not counterfeit. So as someone that is making the boards, if I want to go out and buy FTDI chips or USB to serial converter chips, I need to be 100% sure that the parts that I'm getting are genuine and they are not just very good copies, because there is the risk that FTDI could then update their driver and brick all of the devices that use the non-genuine chips. And even with the best intentions of wanting to make sure I buy the genuine chips, there is still this niggly thing in the back of my mind. What if I'm building boards and shipping them and the supplier I'm getting them from has not got the genuine thing, and then FTDI brick all of my boards? So my level of trust in FTDI doing the right thing, it's not very high. From a technical point of view, I'd probably like to use those chips because they're generally stable and they work on every operating system. You don't have driver problems, so you can be reasonably confident that you'll plug the device into the computer. It will come up as a serial port and everything will work. But there is this thing in the back of my mind where I just can't bring myself to make a device that has FTDI chips on it as the USB to serial converter. So, other options. One is what I've done on things like the Ether 10 and the 11 and basically all of my Arduino compatible boards. They use the same technique as the Arduino Uno, which is they have a second microcontroller on it. They've got an 18MB 16U2 sitting up on here, which is loaded with firmware that just turns it into a USB to serial converter. And in fact, the USB to serial converters, the modules that I sell, do I have one? I've got one, but it's all wrapped in tape. In fact, someone was asking about this quite a few streams ago, just as a funny thing. This is one of my USB to serial converters with the Sonoff programming adapter, and I plugged them together and wrapped tape around them, and then I decided that didn't look professional enough, so I put some heat shrink over the whole lot. So it's just one unified thing. So this is like a programming dongle that I use whenever I'm reflashing Sonoffs. So I just plug that in and I've got a USB interface. And it's all just permanently attached together with white heat shrink. So here's one. So this is the USB to serial adapter. The first version of this was actually designed by my friend Luke Weston, who's also here in Melbourne. And this implements the circuit from the USB to serial converter part of an Arduino Uno with the addition of a 3.3 volt regulator, so that you can switch it between 5 volt mode and 3.3 volt mode, and it gives 3.3 volt digital logic and also 3.3 volts on the VCC supply line, so that you can use this for programming 3.3 volt devices. Now, using the 16U2, I could do that. So basically what I could do is use this same circuit, but then you've got a microcontroller that has to be flashed. So part of the process of assembling the boards then is you have to put a programmer onto it and load the firmware onto it. It also needs a crystal and various other supporting parts. And the cost of something like a 16U2 as the controller is more than the cost of some of the dedicated USB to serial converter chips. Now, what I do like about that approach is that once again it is pretty well universally supported. Because the Arduino Uno reference design is so ubiquitous, it has to work everywhere. There is excellent support for the Uno on pretty much all the platforms that matter these days. So if I went down that track, I could be assured of good compatibility with everything, but it would cost more, and there are more steps in manufacturing because you have to do the firmware flash as part of the process. So other options, there are two others that I'll get into, and this is this is a major sidetrack, but thanks Aaron for that contribution. This is related to that project. Two other options. One is the Scilabs or Silicon Laboratories series, like the CP2104, CP2102, and those sorts of things. Now I know that Seal, the Unexpected Maker, uses the CP chips on his boards and likes them, as far as I know. And I've done some with that as well. I'm just wondering where. I don't have one handy. The first version of the Air Quality Sensor Pro had a CP2102, 2102N on it, and my prototypes of the Sonoff programming adapter have also got a Scilabs CP chip on it. Now the CP chips are nice in some ways, but they need a programming step. Well, at least they. Oh, I just saw a comment from Rob Gannon. Hey Rob, welcome to the stream. So when you put down one of the Scilabs chips on a board, out of the box it will work as USB to serial converter, but it has a number of options that typically need to be enabled. For example, if you want TX and RX LEDs, you need to assign those functions to two of the GPIOs on the converter chip. And if you want your board to be able to draw more than a very small amount of power from the USB port, you need to configure the USB to serial interface chip to tell it to negotiate a higher power level with the host that you plug it into. So typically what I would want to do is have them negotiate the highest power level. So on a standard USB port, 500 milliamps, so that you can then pass that power through to the target device. And to change those settings, what you have to do is use the Scilabs configuration tool. So you've got to have it running on like a Windows machine or on a Mac. I have it running on my Mac. So what happens is that you build a circuit, it works out of the box as a USB to serial converter, but you need to turn some options on. So what you then do is plug it into your host computer. The computer recognizes you've got a new device. You can have a profile set in the management software, and you can say, send this profile to the target device, and it will then set all the options. Like it will tell it, use these GPIOs for the TX and RX LEDs. I want you to negotiate maximum power level on startup. I want you to identify with this particular ID, like the USB VID, and PID, and then and it saves it in non-volatile memory, so that's fine. But once again, it's an extra step. You need to have the configuration software running on a computer and in the factory. So when these boards are being assembled, each one that comes off the line, you plug it into the USB interface, you run the configurator software, and you flash the new config to it. So it's an extra step. So that can be done. One thing that I don't like about those chips though is the pitch of the pins. They are QFNs. They're moderately small. I think they are, from memory, I think they might be 0.5 millimeter pitch or maybe 0.7, something like that. So they're very small. And if I'm farming out assembly, that's fine. Like QFNs are no problem. But for anything where I want to be able to make some of them myself, I just find that it's too much of a pain. Like getting the solder paste right on the 0.5 millimeter pitch pads, and then doing the reflow and having it all working. I don't like QFNs from a rework point of view, just because you can't get probes in, you can't see whether you can't visually inspect them and see whether you've got shorts under the chip or whether you've got open circuit. So you can do functional testing, of course, but then yeah, it's not so nice from a hand assembly point of view. But the CP series chips are pretty good candidates at the moment. I'm going to get onto the fourth option in a second, but I just noticed that there's another thing that's popped up. What's this one? James has just contributed $20 for improving Wi-Fi acceptance factor in your house. So, thanks, James. That's very generous. So, I need to do some labeling. I think what I need to do is get my CNC machine going, doing some text engraving, and experiment with putting ink or paint into the bottom of the engraving and cleaning off the faceplate, so that so that I can have coloured lettering. But James, thanks for your generosity with that. That's amazing. So, getting back to the thing about the USB to serial converters for the Sonoffs, the fourth option, there may be other options, but these are the four that I've considered, are the super cheap CH series chips like the CH340G. And in fact, that is what's on this PCB. This one's not populated, but still. This little footprint here is for a CH340G. If you have used a Wemos D1 Mini, one of those boards that I almost always have, oh yes, here's a perfect example. I have a Wemos D1 Mini with InReach, and this one has a CH340G on it. So a CH340G is a USB to serial converter chip, which in many ways I really like, but there is a catch. It's a Chinese origin chip, so things like the FTDI adapter, even though the chips themselves, I believe, are manufactured in China, the company that designs them is I think it's an American company. The CH340 chips come from a Chinese origin company, and they were designed specifically to make very simple, very cheap USB to serial converters to go on boards like this. The problem, two problems actually. One thing I really like about them is that they're physically large, which sucks if you're trying to make a small board. If you want to make the smallest thing possible, then you want QFN and you want it to be like 3mm by 3mm. But for boards where size is not such an issue and I just want to hand solder stuff, then these SOIC, I think they are, outlines are nice because they've got the big exposed pins. I mean, these are so easy to hand solder compared to a lot of surface mount things. And with a board like this, I don't really have big space constraints, so I just stuck a CH340G on there. Two problems. One, once again, is counterfeits. This silicon, because it's so popular and so cheap, has been counterfeited by many factories, and it's really common to order CH340Gs, have them arrive, and they either don't work at all, like they're just not even the right chip, it's just a package that has been laser engraved, or it's some other chip that has been falsely marked to make it look like it. And yeah, you've paid money and you get the chips and they just don't work. Or it's a counterfeit chip and it kind of works, but then it has problems. But the killer, this is what really drives me nuts with these things, is there is something super seriously wrong with the USB drivers for these on Mac. And to the point where if you have a certain combination of the driver installed and a certain version of the chip, and you plug it in, it'll kernel panic Mac OS. And that boggles my mind. I don't even know how, in this day and age, an operating system can allow itself to be kernel panicked by a USB driver. It's just weird. Internally, the operating system should be partitioning things like USB drivers enough that even if the USB driver itself totally explodes, it shouldn't take out your whole computer. It should just fail itself in some little isolated, segmented way. So the fact that you can plug this board into a Mac and the Mac just spontaneously reboots, that's a killer for me. I hate that. Once again, it takes away all of my confidence in being able to deploy that chip and put it on a board. If it's the sort of thing that if I was making a project for myself and I was sure that I had the right version of the drivers installed and it worked, then I'd be kind of comfortable with it. But if anyone else, if I'm making a board that's going to be used by other people and they're going to plug it into their computer and I've got no control over what drivers they might be running, I've got no idea what they've installed, and there's conflicting information everywhere. You look around for drivers for the CH340G and you'll see people say use this version of the driver and use this version of the driver, and the higher version number is not necessarily the most recent one, and people will say, oh, use this driver that was hacked by this other third party and they fixed the problem, so install that and now it will no longer kernel panic your Mac. That situation, I just can't stand that. I don't want to be shipping out boards, have people plug it in and then their computer reboots. That's rubbish. So even though I put the footprint on this board, so this is one of the prototypes for the Air Quality Sensor Pro, I'm pretty sure I am not going to go with the CH340G on that, and also not going to go with it on the USB to serial converter for the Sonoff programming device. So what I've got into here is one of those situations, like I was talking about before, where I've got a number of options, none of them are perfect, they've all got problems, and as a result I kind of don't make a decision. I need to make a decision. What I'm leaning towards is, for the little Sonoff programming adapter, is using the Scilabs chip. I think I'm going to follow Sion's lead on this because he's been using it very successfully. He's made thousands and thousands of tiny picos, all with the CP chip on it. And from what I can see, drivers are reliable. The chip is small. It's consistently available and you can be sure that it's not going to be cloned. Well, you can't be sure it's not going to be cloned, but the supply chain is, I'm confident enough in the supply chain that I know I could order CP2104s or 2102s or whatever and know that what I'm getting is the correct thing. With things like the CH340G, the FTDI chips, I've just got no confidence. I could place an order in good faith with a supplier that normally does the right thing and get the chips that are the wrong thing. So I'm coming to the conclusion that I think I'm going to use the CP series chip, and I'm also confident now, well, I'm not confident, but I'm as settled as I can be on the pinout that I'm going to use. I'm going to go with it, even though I have not yet got confirmation from IT about what format they might use in future. At some point, I just have to go with it, because who knows, time could go on. Could be another year and I'm still waiting for feedback from IT about what they're going to do. And in the meantime, I've lost a year of opportunity and devices that haven't been released. So this is a very long-winded way of coming back to Aaron's point about the USB-C programmer with the pogo hats for Sonoffs. Because all of this came up just recently, like, this is a project that has been sitting dormant for a year or so, and it's because it's been brought up in recent live streams that it's now all of a sudden back up near the top of my priority list. And it's been annoying me that I've got these boards that have been sitting there unreleased for so long, when all I have to do is make a bloody decision and decide, okay, I'm going to use that chip, and I've got this pinout, I'm settled on the pinout, just do it. So I'm going to just do it. That'll be coming up. Alright, now I've got to try to catch up on some of the things. Oh, I've got some comments in here from Sion, Unexpected Maker, which he'll have some strong opinions about USB to serial converters. So let's see what... Oh, I just woke up my she who shall not be named somehow. So let's see what Sion has about this. Yeah, so if you want custom settings, you need to do a one-time programming thing. Yeah, exactly. So, Sion, okay, so Sion said, I don't do any of that, I use it as is. That's interesting. So, if the out-of-the-box settings could do what I need, that would be great. Maybe I need to look into that a bit more. So, from my experience of using them, I think the default behavior is to negotiate a low power level out of the host. I think it might be 150 milliamps, and maybe for most things that's enough, I don't know, but I've just always been of the approach of negotiating the highest power level with the host. Otherwise you may not have enough current to run whatever device you want. Like if you get a, here's my example again. Say a classic Arduino, like an Uno, or in this case an Ether 10. When you plug it into the host computer, the USB interface talks to the host and it says, I am this type of device and I have these capabilities and I need this much power. So it can say, and by default the host computer will only allow a certain amount of power down to the device, like 150 milliamps. And for a device like an Ether 10, which has to run the WIZnet Ethernet chip and it's got a whole lot of I/O, it typically needs more than 150 milliamps. So one of the very first things it does on connection is talk to the host and say, I need a power budget of 500 milliamps. And the host then says, okay, I will allow you to use up to 500 milliamps. So my approach with setting up USB interfaces generally has always been, whatever I do, just ask for the most amount of power, because you don't know what people are going to be plugging into this device. You don't know what peripherals they're going to have. So maybe I don't need to do that. Interesting. Alright. Okay, where am I up to? So I was wanting to follow down Sion's comments. So Sion said, no, I suspect that was in relation to the suggestion of using CH340s or something else. Yeah, James said CH340 always causes a kernel panic on my Mac with some knockoff Arduinos. Yeah, that's right. It's such a... That's the thing, is that it's unpredictable. You just can't be sure of what's going to happen. You can have two D1 minis, and the USB to serial chips on them are from different batches, and you plug one in and your computer is fine. Plug the other one in and it kernel panics. That's a killer. I just can't live with that. So, and Sion said, currently uses the CP2104 and wants to move to the 2102N. Yeah. So the CP2102N is what I currently have on my little adapter board. I'll pull it out. So, oh no, this one's got a CP2104. Oh yeah, so I've done a couple of different versions of this. This one has a CP2104 on it. This one has a 2102N. I've gone through a few iterations of this. And this is what I mean, is I spin around trying to make decisions about what is the 100% best solution, and the result is that I just don't release any of them. So, yeah, yeah, Sion said they are cheap for a reason. Crap quality, crap drivers. Yeah. All right. My where I'm landing with this is, I think I'm going to continue with the CP2102N, which I have on one of those prototypes, and just live with the fact that it's QFN and it totally sucks for hand soldering. Yeah. Cool. Yeah, Sion said, good. He was about to drive over and smack me in the head. Yeah, I think I'd deserve it if I decided to go with the CH340G. I would need everybody to come over and smack me in the head. So, alright. I'm just about time to wrap up. Oh, and... oh, interesting. So, Sion says the ESP32 requires minimum 500 milliamps for radio calibration. Yeah, that's right. It takes a big gulp of power when it starts up Wi-Fi and gets it out of the box, so no need to negotiate. But if you want TX and RX LEDs and VID, PID settings, you need to one-time program. Yeah. I could probably get away with that. One thing that I'm very interested to hear is, do people care about TX and RX LEDs? So I personally do. On a device that is a programmer, I do like it. I also like it on a target device which has a built-in USB interface, because when you click upload you can see the activity and you can tell that something is happening. It's not just sitting there dead with no progress and not knowing what's going on. So I can totally understand leaving them off for trying to optimize board space and trying to make a really small device. So if it's not something that you're going to be programming often, then leaving TX and RX LEDs off, no problem with that at all. I don't mind that. But the thing is that what I'm doing with this sort of programming interface, the whole point of the board is for reflashing. And I think it's really important to have that visual feedback, that you know that the flashing is working. And you can see the activity of sending the data, and you can see responses. If, for example, you see that the TX LED is flashing and you're not getting anything on the RX LED, you know that your target board is not responding. And because I want to use it specifically, like the whole time you're going to be using this device is when you plug it into something and then you flash it and then you unplug it. So for my particular application, I think TX and RX LEDs are important, but I don't know if anybody else cares. Oh, cool. MXX1805 said, "G'day from Kazakhstan." Hello, Kazakhstan. it is so cool seeing all of the different places that people are coming from. Oh, and James said, be sure to use a 2-meter stick to smack him with. Yeah, got to keep that physical distancing while Sion is slapping me upside the head for thinking about using a CH340G. But it's okay. I'm not going to do it. It's okay. You don't need to kill me. So Sion said, for a dev board, no, not needed. Yeah. Oh, and Tabletronics. Oh, hey. Good to see you here. Said, I use LEDs to determine auto reset failures. Yeah, that's right. And Dodgy says, I do like the visual confirmation. And Aaron said also great for feedback, so you know it's doing something. Yeah, auto reset failures are one of those things that can be really frustrating, and it becomes very quick to diagnose if you do have the TX and RX LEDs, because you'll see that your programmer is trying to send data and you've got nothing coming back on RX. It's a pretty high likelihood that your target device hasn't reset properly. So it's a very quick way of diagnosing that sort of problem. So yeah, I am 100% sure for this project, for the programming adapter, I want TX and RX LEDs. So just because of that, I need to have that one-time programming step of pushing the profile to the CP chip. There's no way out of that. I'm going to have to do it. But that's okay. It's also part of the testing process. It's annoying to... It's an extra step. If I farm this out and I end up having these boards assembled in a factory, like one of the assemblers that I use in China, what it means is that I have to define the test process, and that will include setting up the Scilab's programming environment on a machine in the factory. And I mean, that sort of thing can certainly be done. But if you can avoid it, it's so much better. Because if you think about the situation where you're dealing with a factory and you have a whole process that you have to go through, documenting what the assembly process is, what the testing is, how do they validate that the boards are working, and all of that sort of thing. And I go through the process of getting them up to speed on doing that. Because I'm very low volume, I'm not a big volume customer, I would go through the process, they would make me a few hundred boards, and then it might be 6 months later that I go back to them and say, I've sold all those boards and I need another few hundred. 6 months from now, they've got to go through the process of recreating the environment necessary to do the assembly and the end-of-line testing and all of that sort of thing for this product. Now, the person who ran the tests the first time may not even work at the factory anymore. If they do work at the factory and it is the same person, then they're going to have trouble remembering, how did I set this software up 6 months ago, last time we did a batch of these boards? What settings do I need to use to make sure the profile is flashed properly and that all of the options are set in the CP chip? So, and in the meantime, the computer that is used for the end-of-line testing has probably been reformatted and had Windows put on it again, so they've got to install the software from scratch. The whole thing is, any step like that that you can avoid having to do, you should avoid doing it, because it's just extra barriers, it's extra complexity and more things to go wrong. Speaking from painful experience, yeah, more things to go wrong. And it's really fun trying to diagnose problems running on a computer in China, running Windows in Mandarin, where all of the user interface is in Mandarin. And I've been in the situation before of being on TeamViewer, remotely looking at a Windows, what was it? Windows 2000? I can't remember. It was some very old version of Windows. Might have even been like Windows 98, running in the factory, which was connected to a test jig, and having to navigate through all of the menus in Chinese to figure out why this test procedure is not working. And that's not a fun day. So particularly when I'm not normally a Windows user, which means I can't just pick menu items from memory of knowing, oh yeah, that's that particular menu item. I have to either have another copy of Windows running and say, okay, it's the third menu down is the particular option, so then I pull down the menu in Chinese and pick the third menu down, or be doing translations on the menu items. So that sort of thing would be a whole lot easier if you could just read it natively and you're not 6,000 kilometers or whatever it is away in a different time zone. Alright, Sion said you can buy pre-set up CPs from Scilabs and supply those pre-done. That would be a dream. I don't think I'm big enough volume. I mean, Sion makes tiny picos in quantities of thousands. I'm not working at his scale, certainly in terms of these products. For a lot of the boards that I make, I'll produce them in quantities of hundreds at a time, not thousands at a time. So I don't know how it would fly if I went to Scilabs and said, I'd like 200 CP2102Ns, please, and I'd like them to be pre-configured. They'd probably laugh at me. Alright, I'm going to wrap it up because I'm now past time, but one little last thing. This thing here that people were asking about in the last stream, and Simon was on the last stream. So Simon is my client who owns the company that makes the water trucks that this water cannon goes on. He didn't seem to mind me showing it off, so something I've just been doing. So this is now running off this joystick, and it's a little bit out of focus. Let's see if I can change the camera focus. See if I can reach that way. No. Am I going further out or further in? I'm not sure. Oh no, that was going further in. Alright, I'll go further out. And out. I've got it not block the screen. And then exit. I'm trying to use this awkward little control thing on the camera that's sitting over the top of my monitor. So this is the water cannon with the controller sitting just on it there, which I designed. And at the moment I'm just controlling it off the joystick, but the controller also has a CAN bus interface and other fun things. So what I've just been doing is putting limit sensors on this, so if I bring the cannon right up to the top, it's stopped, and if I pull the joystick back it won't go any further. So I've now got upper and lower travel limits, and I've got left and right travel limits, so I can rotate the cannon from there. It also has an adjustable nozzle on it. You'll hear the relay clicking, but this normally moves in and out. Right now this wire isn't even plugged in. So spin it around there so you can see it. The nozzle isn't even plugged in, so I can't adjust that. But if I put the cable in, I could do it. Anyway, little update on that project. That is very cool. Frank said, are there soft limits? Yeah, there are other limits as well. And there is also current monitoring on the motor drivers, so I can see if, for example, if it collides into something mechanically, then we can detect that. Because one of the bad things is if a limit fails and it, which way does it go? Bring it in close and exit. I wish I could refocus that without it jumping in. Yeah, so bad situations are things like physical objects getting in the way. Maybe a hose gets draped across it, or something gets moved. We don't want to do damage to the cannon or to whatever it is that it hits. So So I've got current sensors on it to detect collisions. Anyway, that is a cool, fun project, and I like talking about it. I just can't show you the details of how it works because it's a project for a commercial client, but it's still a fun thing. Dodgy asked, will the water have any bearing on the movement times? I don't think it does. The way the bearings work, or the way the water flows through the system, shouldn't affect the joints. So I'm just thinking about how to explain this. I don't think I will. I won't go into this question right now. But yeah, there are many of these. The previous versions of these have been put on trucks and they've been in use. And this controller, in fact, this exact controller has been on a truck out in the field working with a council, watering nature strips and things, and then we pulled it back off the truck after the trial, and I've got it here for doing more development. So it does work. Two last questions, and then I've got to stop. So Nikhil said, which smartwatch are you using? This is just a what is it, a fossil something? Yeah, it's some kind of fossil watch, nothing particularly special. In fact, the most use I have for this, it was totally unexpected. What's turned out to be the most useful thing on this is using it as a remote control for podcasts. So I can have my phone playing a podcast and then just pull it up on here and pause or change the volume or whatever. And I did not at all expect that to be my primary use case for a watch, but it's basically a remote podcast interface. And so Aaron asked, this will have to be the last thing, have I done any recent videos showing how to use Eagle and the workflow with Fusion? No, not recently. One of the reasons I haven't done anything with that recently is the whole Eagle integration move. So this could be a big conversation point as well. I'm going to avoid getting into this in great detail. Right now, you can run Eagle in isolation and Fusion in isolation and synchronize projects between them. And that is what I do. However, Fusion now has 90-something% of the functionality of Eagle directly within it, which means you can do schematics and board designs and all of that sort of thing within Fusion without ever opening or using Eagle. And right now, it's early and it's a little bit raw, and the process is not very clear. So I have avoided doing it. I've experimented a little bit with using the schematic and the board tools within Fusion, and I think it's got great promise. But for now, I'm still doing all of my schematic and PCBs in Eagle separately, and then syncing the projects with Fusion for the 3D design portion of it. Ultimately, it looks likely that Eagle will end up, people will get mad at me for saying this, but I think it's likely Eagle will be end of life, because it doesn't make sense for Autodesk to continue developing two tools in parallel that do the same thing. When all the functionality is also within Fusion, then they should just keep developing Fusion, and then Eagle becomes irrelevant. It's like a subset of the Fusion functionality, but it's not there yet. And as Unexpected Maker says, this is dangerous territory. Yeah. This could go on for this topic could go on for a very long time. I'm not going to get into that right now. But part of the result of this is that now is not a great time to be doing things like discussing or demonstrating workflows that integrate Eagle and Fusion, because whatever is done, the relevance is going to decrease over time. So that's something I might get back to. All right, I'm going to have to Oh, and James said the libraries may still work the same, so it becomes easy to maintain two main IDEs. Yes. And Sion said they already stated it's going to be sunset at some point, probably 2021 or 2022. Yeah, that will happen. So at some point, Eagle users are either going to migrate to KiCad or some other tool, or they're going to follow it into Fusion and use Fusion as the main tool, and Eagle will just go away. Both of which are quite valid paths to follow. So I think some people will take that as an opportunity to switch to another tool. That's fine. So, oh yeah, and James's comment about the libraries may still work the same. Initially, they didn't. Oh, excuse me. Initially, and I think just with a fairly recent change, one of the recent releases of Fusion 360, there have been like 2 or 3 releases of Fusion 360 in the last couple of weeks. One of them unified the library management with Eagle, so that the libraries were compatible previously. If you had a that really is time to stop. If you had a library in Eagle, you could then use that same library in Fusion, but then they would deviate. Changes made in one would not be reflected in the other. Now they are both using the same back-end management system for the libraries, but I think that change has happened literally like within days or within the last couple of weeks, that they have been modified so they now can use the same back-end. So the degree of merging between them is increasing over time. I am going to have to jump off now because my voice is failing. I need to cough, have a drink, maybe get some lunch. But thank you all for coming and hanging out with me on a lovely Sunday morning again, or Saturday night, or whatever it happens to be in your time zone. And I will be back next week with another SuperHouse Sunday session. So in the meantime, think about things that we should talk about. And maybe by then I will be able to bring guests on as well. So it is time for me to sign off. I want to say thank you again to the people that contributed on the super chats. That is really cool. I'm quite frankly stunned that that you've done that. That is fantastic. So I'm going to say goodbye and go out and enjoy your weekend. Thank you and good night.